Hi folks, this is College Algebra, Take Home 9. We're asked to solve the following problem using an augmented matrix. Carl has 11-7 Pokemon. All his Pokemon are either Snorlaxes, Munchlaxes, or Gengars. There are twice as many Snorlaxes as Munchlaxes, and the number of Gengars is equal to 3/10 the total Snorlaxes and Munchlaxes. How many Pokemon of each does he have? Okay, well, we have three unknowns here. So let's let S be the number of Snorlax, M be the number of Munchlax, and G be the number of Gengars. So since all of his Pokemon are either Snorlaxes, Munchlaxes, or Gengars, and he has 11-7 Pokemon, we have a total Pokemon equation. I guess if we go alphabetically, we'll do G plus M plus S equals 11-7. There are twice as many Snorlaxes as Munchlaxes. Okay, this is where a lot of people made a mistake on it. So let's look at the Snorlax-Munchlax equation. Twice as many Snorlaxes as Munchlaxes. So if I have 10 Munchlaxes, I have what? 20 Snorlaxes. So whatever the Munchlax number is, I double it to get the number of Snorlax. I have twice as many Snorlax as Munchlax. The number of Munchlax times 2 is the number of Snorlax. And the number of Gengars is equal to 3/10 the total Snorlaxes and Munchlaxes. So the number of Gengars is equal to 3/10 the total of Snorlaxes and Munchlaxes. So it's 3/10 times the quantity S plus M. So this gives me three equations, and I have three unknowns. We need to put these in more of a standard format, though. The top equation's fine, because we get all the variables on one side and the constant on the other. Here we need to do the same thing. So if I subtract the S over, I get 2M minus S is 0. And here I can distribute the 3/10 and then subtract that over. And get 0 over there. So this is what we have now. We can substitute into our matrix. Okay, so here are those three equations. Now before we encode them into a matrix, we've got some fractions down here that you probably would rather not deal with straight away. So we can go ahead and multiply both sides of this equation by 10 and get something a little more manageable, at least at the start. So both sides by 10, I'm going to get 10G minus 3M minus 3S is 0. And now we'll go ahead and shove that into the augmented matrix. So remember, in our augmented matrix, we're going to have a row for each equation, and we're going to have a column for each of the coefficients for the variables. And then an augmented matrix then is going to have a vertical bar, and here you're going to have the constants. So our first equation will be encoded as 1G, 1M, 1S equal to 11-7. The second equation, there's 0 G's, 2 M's, negative 1S equal to 0. In our last equation, we have 10 G's, negative 3 M's, negative 3S equal to 0. So this is our augmented matrix. So we're going to go ahead and follow the Gauss-Jordan elimination algorithm. We have a leading 1 here, a 1 in the upper left-hand corner. We're going to use it to get zeros underneath it. We already have a 0 in row 2. We just need a 0 in row 3. So what we're going to do is we're going to replace the row 3 that we have with row 3 with negative 10 row 1 plus row 3. So I'm not replacing row 1. I'm going to keep him as is. I'm not replacing row 2, so I'm keeping him as is. So for the new row 3, I take negative 10 times 1, add that to 10, and that gives me 0. Negative 10 times 1 plus negative 3 is negative 13. Negative 10 times 1 plus negative 3 is negative 13. Negative 10 times 1177 plus 0, negative 1170. The next step is to get a leading 1 in this position. I can accomplish that by dividing row 2 by 2. So row 1 I'm keeping as is. So we're really dividing this equation, both sides of this equation, by 2. 0 divided by 2 is 0. 2 divided by 2 is 1. Negative 1 divided by 2 is negative 1/2. 0 divided by 2 is 0. And then row 3 I'm keeping as is. The next step in the Gauss-Jordan elimination is to get a 0 beneath the 1 here. So to accomplish that, I'm going to replace row 3 with 13 row 2 plus row 3. So row 1, I'm not replacing him, I'm keeping him as is. Row 2, as is. And here's row 3. 13 times 0 plus 0 is 0. 13 times 1 plus negative 13 is 0. 13 times negative 1/2 is negative 13 halves. Negative 13 halves plus negative 13 is negative 39 halves. 13 times 0 plus negative 1170 is negative 1170. The final step then to get this into row echelon form is to get a 1 in this position, and I can accomplish that by multiplying row 3 by negative 2 over 39. 0 times negative 2 over 39 is 0. 0 times 2 over negative 39 is 0. Negative 39 over 2 times negative 2 over 39 is 1. Negative 2 over 39 times negative 1170. Well, believe it or not, 39 goes into 1170 evenly. It goes in 30 times, which makes this a 60. Now that we have it in row echelon form, we can decode this from the matrix. So the first equation, I have 1g plus 1m plus 1s is 1177. Equation 2, I have 1m minus 1/2 s is 0. And equation 3, I get s equals 60. So with s equals 60 now, I can get m. M equals 1/2 s, so it's going to be 1/2 of 60, which is 30. And here I know what g is. It's going to be 1177 minus m minus s, which is 1177 minus 30 minus 60. That's 1177 minus 90. So I'm going to squeeze it in here. G then is 27. So my final answer, I have 60 Snorlaxes, I have 30 Munchlaxes, and I have 27 Gengars. And that'll do it for Take Home 9.